The implementation of k-means clustering for customer segmentation involves applying the k-means algorithm to group customers into distinct segments based on their similar characteristics, such as income and spending behavior. This unsupervised learning technique helps business identify different types of customers like high spenders and budget shoppers by analyzing data patterns. Through segmentation, company can better understand customer needs, design targeted marketing strategies, and improve overall business decision making. So the advantages of k-mean clustering for customer segmentations are simple and easy to understand and implement, efficient and works well with large groups. And disadvantages of k-mean clustering are requires specifying the numbers of clusters in advance, sensitive to outliers and noise in the data. So the first one is importing required libraries. So the libraries are import pandas as PD and import matplot library .pyplot as PLT. The second one is reading the data set. Reads the mall customers.csv into a data frame called data. Data.head displays the first 5 rows to check the data. The third step is checking data information and missing values. Data info shows data types and how many non-null values each column has. And data is null.sum checks the missing null values in each column. This ensures the data is clean before applying clustering. The fourth one is importing and setting up k-means. From sklearn.cluster import k-means wcss equal to bracket import the k-means class from skict learn, a machine learning library. WCSS within cluster sum of squares stores the distance between points and their cluster center. It helps decide the optimal number of clusters. The fifth one is using the elbow method to find optimal clusters. For I in range, k-means equal to k-means. This loops through cluster number from 1 to 10. K-means creates a k-means model for I clusters. Init equal to k-means improves cluster center initialization to get better results. Data.iloc selects columns for index 3 onwards, typically annual income and spending score. .fit trains the k-means model on the data. .inertia gives the WCSS value which we store in the list. The sixth one is plotting the elbow curve. Plots the number of clusters versus WCSS. The point where the curve starts to bend, elbow, indicates the optimal number of clusters. This helps decide n clusters. The seventh one is building the final model with 5 clusters. Create a final k-means model with 5 clusters. .fit trains the model. Predict assigns a cluster number 0 to 4 to each customer based on their income and spending level. Ypredict stores the cluster labels. The eighth one is adding cluster labels to data. Adds a new column called cluster to the data frame. Each row now indicates which cluster that customer belongs to. The ninth one is separating data by clusters. This creates 5 new data frames, each containing customers belonging to clusters 1 to 4. Visualizing the clusters. Each plt.scatter plots the customer in one cluster with a different color. The x-axis equal to annual income, the y-axis equal to spending score. plt.legend shows color labels. Plt.title names the graph as customer segments. And